Hey Pre-Calculus, this is Mrs. Martin here today with your notes on the unit circle. Congratulations on finishing up Unit 2, and I hope that you're all excited to start Unit 3 with something that's hopefully a little familiar to you. And while some of you have expressed to me that unit circle wasn't your favorite thing last year, I'm hoping that maybe it'll become something a little more comfortable after we go over it once more together here. So I'm going to try and stay very, very color coordinated and walk you through this unit circle in the first part of this video. And then in the last part, I'm going to explain how you are going to submit your assignment for this intro to the unit circle, or I guess more like a continuation since you've seen it already. So again, first part of the video will be filling out this unit circle together. And in the second part of the video, I will explain how you will be submitting your assignment for today. So let's begin with degrees, because I think degrees are something that we can understand a little better from geometry. I'm going to start over here on the right, positive part of the x-axis, and we can go ahead and call that 0 degrees because we haven't traveled along our unit circle. So just as a reminder, we're starting here, and know that the unit circle's radius is 1. So we're starting here, and we're traveling counterclockwise to complete this unit circle. And mostly the reason for that is because this is quadrant 1. Let's label these. So this one's quadrant 1. This one's quadrant 2. We've got 3 down here. And we've got 4 on the bottom right. Okay, and that's standard for math in our coordinate plane. And because of that, we start over here in quadrant 1 and travel around counterclockwise. Okay, and so to continue filling this out, I think most of us are in the habit of remembering our special right triangles, and we know they come in 30s, 45s, and 60s. Maybe one that we want to look at next before we start filling the intermediate ones in is the fact that this is a right angle. This is perpendicular because we know that the x and y axis cross each other at a perpendicular, and so I can actually name this one 90 degrees. That might be one that we're familiar with too. I mean, it's always good to start with the stuff we know. Something else you might remember is that over here on the left, we hit 180 degrees, right? We've got this supplementary set of angles where together they make a straight line. Supplementary, they are 180 degrees. Continuing on, if I add 90 degrees to that 180 so that I have another perpendicular down here, I know that this bottom one is 270 degrees. And to finish off the quadrants, I know to end with a circle, to go in a complete circle here, we've got 360 degrees. Okay. And so as we try to fill out the smaller ones, again, I'm hoping that you remember your special right triangles. And we've got 3 of them, and we'll talk about them more later. We've got the 30. We've got the 45. And we've got the 60. Okay, and using those, and hopefully in Algebra 2, you remember you had the little pieces of paper, those little tiny triangles, and you were kind of fitting them into the unit circle a bunch. We're using those with this as our origin. Okay, this is always the origin here, to make the rest of our points along the unit circle. So here we've got 30 degrees, 45 degrees, and 60 degrees. And I can continue to add here. From 90 degrees, if I know this is 30, then I know this must have been 150, right? So that's how that works. And I can continue adding along. So if this one was 60, then I know this should have been 120. 120 plus 60 is 180. And then for the 45, we've got 135. So same thing. I'm just kind of, if this is 45, I'm subtracting it from 180 to get the leftover. Okay, so continuing on now, I've got to add because I've got 180 plus 30, okay, I get 210. 180 plus 45, I get 225. 180 plus 60, because now we're getting into the 60s, right? So 180 plus 60, 240. And then we've got our 270 there, so we're good to go with that. And then I might want to start that subtraction thing again. So I've got 360, I'm going to take away 30 to get 330 left. Take away 45, so I get 315. And then take away 60, that I get 300. Okay, so lots of ways of going about filling in the unit circle, but I do feel like degrees are probably a good way to go at the beginning. And notice that I just kind of puzzled it out, tried to add up things, and so on and so forth. So take your time trying to figure these things out. And again, hopefully these numbers are familiar and maybe you're recognizing them from last year. Now, radians, let's go and talk about radians since we just finished talking about degrees, because degrees and radians are, in a sense, interchangeable. And when I mean interchangeable, I'm talking about them in terms of conversions, right? The same way we would convert inches to feet and feet to yards and so on and so forth. And so degrees actually can be converted into radians and then radians to degrees pretty easily. Now, just to kind of talk about this, what is a radian, right? So some of you might have asked yourselves that last year and maybe didn't get a chance to talk about it. And really a radian is the measurement of the radius along an arc. Okay, it's an arc length. So here it is, arc length that is equal to the radius. Okay, that is a radian. And so the radian that we knew best probably was the one that covered the whole top half of the circle, which is pi. And we know that pi is interchangeable to like 180 degrees. So those are equivalent, okay? Two different units, but equivalent values. Equivalent measurements happening here. And so with that being said, I can actually go ahead and jump into my unit circle and write pi for my radians. But this 180 being equal to pi thing is really important because it allows me to write this and this. Because if pi and 180 are the same thing, that means these are all equal to 1. Okay, and it's going to help me convert my degrees into radians. So that's one option when we're going about converting all of these degrees to radians. So let's look at a few together. And I'm going to leave those special right triangles up there because we might need them. Okay, so my radians, I've got 90 degrees. But I don't want them to be degrees anymore. I want them to be radians. So one option I have is to use pi over 180. Now, why use pi over 180 and not 180 over pi? Really, my reasoning for that is so that I can cancel out the degree symbols, okay? That's the reason I decided pi over 180. And so I can solve this 90 pi over 180 I can do some simplifying here, and I get pi over 2, which is hopefully a familiar radian for you guys. Pi over 2. And we can do this with the rest of the degrees around the unit circle, and some of you can do that fairly quickly, especially if any of you are quick with your mental math here. But oftentimes, it's not really convenient. There are other ways besides just converting all the degrees, especially if you don't have the degrees at the ready. So here's another method I developed with filling in the radians on a unit circle. So another method that I used for filling in the unit circle is by making a circle and cutting it up into pieces. And so the first way I'm going to cut it is in half. Okay, and when I cut it in half, I know that this is pi and this is 0. 0 degrees is equal to 0 radians. I can go ahead and fill that one into my unit circle. And so something interesting happens when I start to cut up the unit circle. So I can start, let's start with quarters. And actually, let me only cut up the top half. Okay, so I'm starting with the top half and I cut it in quarters. And notice that I have 2 pieces. And so when I have 2 pieces, I have pi over 2. So how many pieces did I have? I had 2 of them. This is the first piece. So technically this is 1 pi over 2, but we would probably never write 1. So pi over 2. So that's one way of looking at it without converting using pi over 180 or 180 over pi. In this same way, I could instead cut my pi, and remember pi is only half, not the whole thing. I can cut this top half of my unit circle in 4s. So now all of a sudden, I've got denominator 4. And as a matter of fact, let's put this one under 4 too, just to see what happens. When I do that, how many pieces are here? 1 pi. How many pieces when I get here? 2 pi's. 3 slices of pi, and 4 slices of pi. And notice what happens. The 4's cancel, so I still have pi. Over here, 2 over 4 becomes pi over 2 when I simplify. And so I just found the radians for my 45, 45, 90 triangles, all my 45s here. So now I can come over to my unit circle and fill in pi over 4 and pi, 3 pi over 4. Now you might be wondering, what about the bottom of this unit circle? Well, actually, it works the same. I've still got denominator 4's, except this time, I started 1, 2, 3, 4. I'm going to continue with that. 5, 6, 7, and as a matter of fact, this one becomes 8. And so when I simplify a little bit, I can simplify a few of these things. 6 pi over 4 becomes 3 pi over 2, which is hopefully familiar. And 8 pi over 4 becomes 2 pi, which we know is a full circle. So instead of trying to convert all of these degrees, I could try to mentally chop up my unit circle and just count like a clock. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7, 8. And it helps me systematically fill the rest of these in. 5 pi over 4. I'll use the reduced one, 3 pi over 2, 7 pi over 4, and 0 or 2 pi. Okay, so that's how we're dealing with the 45, 45, 90s. Let's look at the 30s. Now, surprisingly or not surprisingly, it depends on how you look at it, the 30s and the 60s go together because they have a common factor. Okay, so instead of doing 30s and 60s separate, we can actually do them together. So I'm going to go ahead and chop up this unit circle into 4s, and then I'm going to chop them into 30s, okay? So here's 30, 60, 90. And I'm going to do that in all my quadrants. Okay, each one of those was 30-degree slices. Okay, and so now I'm going to count how many slices are in pi. And remember, pi is only the top half. So from 0 to pi, how many slices did I have? So if I look through here, I've got 1, 2, 3, 4, 5, and 6. Okay, so since I have 6, I'm going to turn all my denominators into 6s. So divided by 6. I won't do 0 because nothing happens to that one. I'll do this one, 6. I'll continue. Okay, so I've got all these with the denominator 6 because I had 6 slices in the top of my pie. And now I'm going to go through and just fill in how many slices of this circle I'm giving. Okay, so I've got 1 slice here, so 1 pie, 2 slices, 3 slices, 4 slices, 5 slices, and 6 slices. And so just to confirm we're not making any mistakes here, the 6's cancel to leave me pi like I needed. And over here, 3 pi over 6 reduces to pi over 2. So again, we're on the right track. I'm just kind of checking to make sure I'm not making any mistakes. And then to continue, I've had 6 slices left off here. I'm continuing with 7 pi, 8 pi, 9 pi, 10 pi, 11 pi, and then over here, technically, again, I've got 12 pi over 6. And so once more, I can reduce some of these, right? This guy becomes 2 pi, which is good because that's what it should be. This one can be reduced to 5 pi over 3. 3 pi over 2, awesome, we needed that to be the case also. 4 pi over 3. Over here we can reduce some, 2 pi over 3. And 1 pi over 3. Okay, so some things can be reduced, and I know my unit circle is looking a little crazy because you have so much information on it, but bear with me and rewind if you need to. But I just, again, chopped up these slices, 1, 2, 3, 4, 5, 6 slices in pi. And remember, this is pi, not the circle. And using that slice number as my denominator, I can go ahead and fill in my radians by just filling in the unit circle systematically. I learned this when we had to do the unit circle over and over and over again every Friday in my math analysis class in high school. So you just kind of learn techniques of how to be systematic about it and how to get it done as quickly as you can, while still understanding how the unit circle is divided, how it's broken up. Okay, so I'm going to go ahead and go through this unit circle and fill in the rest of my values. Okay, so now we've got our degrees and we've got our radians. What about this nonsense with the ordered pairs? Okay, so let's talk about that. And to talk about that, we need to look back at these special right triangles that we drew here at the beginning. So the special right triangles actually had some information that we went through when we were in Algebra 1, and that information was that we had some special sides given 30, 45, and 60. The first was that we had root 2 over 2 for the 45-degree triangle. And the reason that works is because I'm sure many of you for Algebra 2 memorized this thing. Okay, our Pythagorean theorem. And if I do that with these values here, root 2 over 2 squared plus root 2 over 2 squared, we get 2 over 4 plus 2 over 4, which is 4 over 4, and that's 1, which is the unit circle. Okay, remember our radius for the unit circle is 1. And if this is our radius, then we're good to go. So with that in mind, I'm not going to really talk too much in this video about where these values come from. That would be another discussion maybe we can have in Zoom if you don't remember where the values of the unit of the special right triangles come from. For now, I'm just going to write them in as givens, given information that we had from last year, okay, just to save us a little bit of time. So for 30, we have root 3 over 2 and then 1/2. And then 60, it was the opposite because really a 60 is just a 30 flipped over on its side. Root 3 over 2 and 1/2. And so we can use this information to go ahead and fill in all the points on my unit circle. So imagine that your unit circle is positioned at the point 0, 0. Okay, we're at the origin for the center of our unit circle. And so when we look out to our right, knowing that the unit circle has a radius 1, that means that this point here has to be 1, 0. Okay, it hasn't moved up or down on the y-axis, but it has moved out to the right a total distance of 1, again, because it is the unit circle. Okay, so by definition. And so I can fill in all of the, I guess, the cardinal points, if you want to think of it that way, north, east, west, south. We can go ahead and fill those in. So if I come up here to 90 degrees, again, thinking about the origin, I've moved up 1 on the y-axis and I've gone nowhere on the x, so that's 0, 1. Moving out to the left over here, I've gone to the left -1. And I've gone up and down nothing, so that would be 0. And then down here at the bottom, I travel down -1, so that's my y value, and I've gone nowhere on the x. Okay, so filling in those corners hopefully won't be too bad because we remember what the radius is, and we know that the radius is the same anywhere I'm looking on the circle. That's just how it's built. And now I can use these triangles to fill in the rest of my unit circle. So right here, I'm looking at the 30 triangle. Here it is. Okay, and I know that going up, my 30 triangle is 1/2. So this side is 1/2, and this side is root 3 over 2. So thinking about the x direction, I've got root 3 over 2. And I'll write that over here. And thinking about the y direction, I've got 1/2. So I'm going to have to write those in my unit circle, but let me get rid of all these lines so that my unit circle looks a little decent. Okay, so again, my x value here is root 3 over 2, and my y value is 1/2. Just kind of overlaying the 30-degree triangle on top of there. For the 45, it's pretty easy. We know root 2 over 2 for x and y because the horizontal is the same as the vertical. And then for the 60, my horizontal is 1/2, so there's my x. And my vertical is root 3 over 2, so that's my y. Okay, and again, I apologize for this crazy looking unit circle. Hopefully you're filling one in for yourself that is a little more neat. So that takes care of the first quadrant. What about quadrant 2? The triangles kind of look like they're flipped around a little bit. And the best tip I can give you for filling out the second quadrant is to remember that all your x values are negative because you're on the negative side of the x-axis. So with that in mind, I'm just going to go through and put negatives for all my x values. And then I'm going to do the same thing I did before. For a 60-degree triangle, because remember this would be a 60-degree special right triangle. For my 60, my x values are 1/2, and my y values are √3/2. For my 45, I've got √2/2. And for my 30, the horizontal is √3/2, and the vertical is 1/2. Okay, so I'm just kind of going about this unit circle, finding the ordered pairs. Finding the ordered pairs by mentally overlaying the special right triangles and keeping in mind how the coordinate plane works and where the negative should be. So with, saying that out loud, let's think about quadrant 3. In quadrant 3, the x's and the y's are negative. So with that being said, I can probably just go through and make all my x's and y's negative so I don't forget later. And then again, use the 30, 45, 60 triangles to create the ordered pairs throughout the rest of the unit circle. So I will admit, the unit circle does end up looking a little cluttered when you finish adding all the information that you gather from it, but it is a very information-filled tool that you have for yourself if you can manage to understand the patterns, because really the unit circle is a bunch of patterns, okay? And if you can understand where those patterns are coming from, it's going to make it a lot easier to fill it in without you necessarily having to memorize it, okay? None of the unit circle for me is memorized, but instead it's more of a pattern-based set of numbers and ordered pairs and conversions. So that's going to take care of the information for the unit circle. Okay, I'll go ahead and let you fill out quadrant 3 and quadrant 4. It's going to work out the same. I'm sure there's plenty of unit circles for you to also look at online just to confirm that your work is correct. And now I'm going to go over how you will be submitting your activity for today. Okay, so here I am on your Schoology page, and I'm going to scroll all the way down here to the bottom to today's date and begin Unit 3. And so I've got some information for you here. Please read this. It talks about what we're doing today and the unit circle. And now that you've watched the lecture, here's a tutorial about how you're going to submit your assignment for the beginning of this unit circle or this Unit 3 activity. So I have a link down here. I'm going to click on it. It's the unit circle game. Okay, and you don't have to log in. You don't have to sign up. I'm logged in right now, but it's not very necessary. And what you're going to do is you're going to press play. Okay, and it does time you. And it asks you questions here in the yellow. And our job is to go through the unit circle and click on the appropriate place for this value. Now, if you've got your unit circle out next to you, put it away. I really want to just see how much you can do on your own. Okay, it's not about having the unit circle next to you and just filling it in. It's more about what you can do in your head without having the unit circle as a reference. Okay, it's kind of more just for fun and to see how proficient we've become with the patterns in the unit circle. So my time's ticking. I'm going to go ahead and start filling some of these in. So 210 degrees, I've got 180 here plus 30 would give me 210. And I got it right. It turns green. I did a good job. Now let's say 11 pi over 6. Ooh, I'm not really sure. And I click. I know the radians have to be on the inside because those have little degree symbols. So I'm just going to click here. Uh-oh, I got that one wrong. It tells me to try again. So I'm going to keep looking. And it records those things. Okay, not a big deal. It tells me how many I've got left. So I'm going to go around 11 pi over 6, this one. And I got it. Now it's yellow. because I got it wrong the first time, but I figured it out after that. So that's fine. It's not the end of the world. And I'm going to keep going through this. 11, I got pi over 3. I've got 5 pi over 6. Okay, now we've got negative 3 over, I'm sorry, positive 3 over 2, which was the long side. And, oh, but negative 1/2, so it's got to be down here. Okay, so I'm just filling out my unit circle this way. Negative root 2 over 2, I know it's going this way. And then a positive, I know that's a 45, so I'm going to pick that one. And you can fill out the rest of this on your own. When you are done, so you've completed all of these, it's going to say 0 here. It's going to say how many you got right, how many you got wrong. You'll get a percentage. You'll have a time. When you're all done, I want you to screen capture this in some way. On my computer, I have a button that says print screen. I know a shortcut. See, here it is. I just printed it. Macs have a shortcut. I'm sorry, I don't really remember what it is, so you might have to look it up. Your other option is to grab your phone, of course, and just take a picture of your screen. If you're doing the game on your phone, you can always just screenshot whatever's on your phone. And you're just going to submit that picture to me here on Schoology. So coming back here on Schoology, you'll have a submit assignment button here, and you can submit the image. I'm not going to be taking off points if you don't get 100%, okay? So if you've got some wrong here, that's not what the purpose of this is. The purpose of this is for you to try a couple times and try to beat your last score, okay? Try to best your score every time you play. So you're just competing with yourself. And do it enough times that you start to feel a little more comfortable with it. Try not to submit to me your first attempt. Try to do it a couple of times, unless of course you just knock it out of the park and get 100% the first time. But if not, try to beat your best score and submit that. So again, play the game, capture the screen in some way, either on your phone or on the with the print screen option on your computer, and submit that image here to show me that you've attempted the unit circle game. All right, and do your best with this. The unit circle really lays the groundwork for the rest of Unit 3 as we continue with trig and use trig functions and use the things that the unit circle has to offer in order for us to complete different properties, kind of like what we were doing with log. I think you'll really like it if you like the log stuff. So if you have any questions, there is an option to leave comments here if you like. That's optional today. I know usually I set up a discussion, but since you're submitting the unit circle activity, the comment portion is optional. Leave your questions here, leave your concerns here. You can also message me, and that's all for today. So take care of yourselves. I hope to hear from you soon. Thanks to all of you who are always making our Zoom meetings on Tuesday. We usually have a pretty good time, and we get a lot of not only math done, but a lot of conversation happening and catching up. And I hope you continue to stay safe, and I hope to hear from you all soon. Bye.